Hello, good day viewers. In this tutorial, we are going to generate formulas for these three summations. We have the first one, which is a summations of C from 1 down to n. We have the second one, which is summations of K from 1 down to n. And the last one, summations of K squared from 1 down to n, for which C is a constant and K is a variable. All right, let's get started. The first one, we would like to generate a formula for the summation of C, which is a constant, from 1 down to n. Remember, constant could be 1, 2, 3, 4, 5. All these numbers are constants. So what if we have the summation of, let me say 3, from 1 down to, let's say 5. This is the same thing as adding series of 3 in 5 places, right? 3 plus 3 plus 3 plus 3 plus 3. 1, 2, 3, 4, 5. And since multiplication is another series of addition, we can say that this is the same thing as what? 3 in 5 places. They are all the same. So what if we should replace this 5 with n? For example, summation of 3 from 1 down to n. It is the same thing as replacing 5 with n, because 5 is equal to n, right? So this is what? 3n. As simple as that. But the question is, what if we replace 3 with c, because c is also a constant? So finally, you can see that the summation of c, which is a constant, from 1 down to n is simply n multiplied by c. So we have established a formula for the summation of a constant from 1 down to n. We are done with the first one. Now let us take the second one, where we want to establish a formula for the summations of k, for which k is equal to 1, 2, 3 up to n. So number 2, the summation of k, for which k here is a variable, from 1 down to n. To simplify this, we can replace the first term would be when k is equal to 1, right? Plus when k is equal to 2, plus when k is equal to 3. You keep on adding up to when k is equal to n. That is the last term. Okay, since we established this one, we can establish another one. This time around, I would like to start from the last term to the first term. They are all the same, because if we say 1 plus 2 plus 3, it can also be written as 3 plus 2 plus 1 in reverse order. So I would like to write it in reverse order, all the same. So we have the summation of k from 1 down to n. This will be equal to n, right? Plus n minus 1, because we are reducing the terms up to 1. Plus n minus 2, you keep on adding up to 1, right? So now let us add these two summations together. From left to right, you can see this and this are all the same. So we have two quantities of the summation of k from 1 down to n. And this will be equal to, we keep on adding this, will be n plus 1. If you add this and this, you're still going to get n plus 1, because 2 minus 1 is 1, right? So we have n plus 1. This and this will also give us n plus 1, because 3 minus 2 is 1. We have another n plus 1. You keep on adding after the last term, which is n plus 1 again. N plus 1. How many n plus 1 do we have here? N number of n plus 1. So this is equal to n number of n plus 1, because we don't know how many they are. This is the same thing as 2 multiplied by the summation of k from 1 down to n. And since we are looking for this, remember this is exactly what we are looking for, right? That is number 2. Look at it here. We can divide both sides by 2. So finally, the summation of k from 1 down to n is equal to n multiplied by n plus 1 divided by 2. As simple as that. So we are done with the first and the second one. Then we need to take the last one, which is the summation of k squared from 1 down to n. So number 3, we would like to evaluate the summation of k squared from 1 down to n. This is the same thing as 1 squared. That is when k is equal to 1. When k equal to 2, we have 2 squared, 3 squared. You keep on adding this up to the last term, n squared. And if you evaluate this, you have 1 plus 4 plus 9 plus dot 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 up to n squared. So if you look at this series carefully, it is neither arithmetic nor geometric. So we are going to apply a logic in generating this formula. First of all, I would like to start with difference of two cubes. How is difference of two cubes? If you have a cubed minus b cubed, this is the same thing as a minus b multiplied by a squared plus a times b, then plus b squared. This is what? Difference of two cubes. So the logic we would like to apply here is to take difference of two consecutive cubes, just like 3 cubed minus 2 cubes. So you can see that 3 here is greater than 2 by 1. So we're going to apply the same principle here. So if we have n cubed, then we're going to have minus n minus 1, because you can see that this is less than this one by 1. So now let us apply the same formula. This will be equal to, for which a is n here and b is n minus 1. Let's substitute. This would be n minus b, but b is this. If you minus this, you have minus n plus 1, because the minus is going to affect the two terms. Then in the other bracket, we have a squared, and a is n, so we have n squared, plus a, which is n, multiplied by b, which is n minus 1, n minus 1, then plus b squared, and b squared is n minus 1 squared, n minus 1 squared. So let's simplify this. N cancel n, we have only 1, and 1 times this will be that. So this is equal to n squared from the other bracket. N times n is n squared. N times negative 1 is negative n. Then we move to the other one. This is binomial expansion. You take the first term, you square that, minus, because of that minus sign, 2 times n times 1, that is 2n. 2n. Then minus 1 squared is positive 1. We are still simplifying. How many n squares do we have? 1, 2, 3. We have 3n squared. 3n squared. Then minus 1n minus 2n is minus 3n. Then lastly, plus 1. So this is just the expansion of n cubed minus n minus 1 cubed. Then secondly, I would like to reduce these two numbers. This is n. I would like to take n minus 1. We are reducing the number. Minus, we reduce this one by 1, it becomes n minus 2. N minus 2. So this is equal to, all we have to do is to substitute n equal to n minus 1, because you can see here we have n, here we have n minus 1. And the right hand side is written in terms of n. So we are just substituting n equal to n minus 1. So this will be 3n minus 1 squared, right? Minus 3n minus 1, then plus 1. Let's take another one. We are now going to reduce this one by 1. It becomes n minus 2 cubed minus n minus 3. We are reducing it by 1 as well. This is equal to 3 multiplied by n minus 2 squared minus 3 times n minus 2, then plus 1. I would like to keep on moving up to 1, because remember that this is a sum of what? Perfect squared numbers from 1 down to n. So we would like to take 1 to n. We have started with n. We are going to stop at 1. Remember, this is where we have n cubed. We have a number which is less than n by 1. We keep on reducing it up to 1. So this is up to, let me use 2 here, 2 cubed minus 1 cubed. This is equal to this 3 multiplied by, this time around, instead of n minus 2, we have 2, right? So we have 2 squared minus 3 times 2, then plus 1. Then I would like to take the last one, which is 1 here, 1 cubed, minus 0 cubed. This is equal to 3 times 1 squared minus 3 times 1, then plus 1. So now we are going to add all of these times together from left to right. Let me start from the left hand side. If you want to add all of these times to the left hand side, just observe we have negative n minus 1 cubed here, and we have positive n minus 1 cubed, so they will cancel. This and this will cancel definitely. This and this will also cancel. And the next time here, remember we have a lot of other terms. Let me extend this one as well. We have a lot of them. So from here, the next time here would be the same thing with this one, so they will cancel as well. And if you come down here, we have a term here that will correspond to 2 to the power of 3. They will also cancel. Then we have 1 to the power of 3 negative will cancel with this one. So you can see to the left hand side, we only have n to the power of 3 minus 0 to the power of 3, which is the same thing as n to the power of 3. So to the left hand side, we only have n to the power of 3. And this is equal to the other side, we have 3 times. Each expansion have 3 times. 1, 2, 3. So let's start with the first term. You can see all the first times contains a factor of 3. Look at it here. So we're going to factor out the 3. Then you can see the pattern. We have 1 squared plus 2 squared plus 3 squared plus 4 squared up to n squared. What can you remember about this? It is the same thing as this one. Look at it. 1 squared plus 2 squared plus 3 squared up to n squared, which is just the same thing as the summation of k squared from 1 down to n. So this is the summation of k squared from 1 down to n. The minus, because of this minus, you can see all these terms contain minus, and they have a factor of 3 as well. So we factor out the 3. So what do we have? We have 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus up to n. And what is that? What can you remember about that? Just look at it here. 1 plus 2 plus 3 plus 4 up to n is the same thing as summation of k from 1 down to n. So we have summation of k from 1 down to n. And lastly, we have 1 plus 1 plus 1. This is what? N number of ones. They are all ones. And that's exactly the first one we started with. You see that? It is the same thing as NC, for which C is that 1. N times 1 is N. So we have N here. Okay. Remember what we are looking for. We are looking for the summation of k squared from 1 down to n. So we can make it the subject. So 3 multiplied by the summation of k squared from 1 down to n would be equal to this. If you take this one to the other side, it becomes positive. So we have n to the power of 3 plus 3 multiplied by the summation of k from 1 down to n. Then as this crosses over, it becomes negative n. But let's simplify this. Remember, we already have this in our previous simplification. And what's that? You can see that right here. It is the same thing as n times n plus 1 divided by 2. So 3 multiplied by the summation of k squared from 1 down to n is equal to n to the power of 3 plus 3 multiplied by n times n plus 1 divided by 2. Then we have this minus n. I can factor out n from all of these terms. So this is equal to n outside. Inside, from this one, we have n squared. Then plus 3. This n is already outside. We have n plus 1. Then minus 1 because the n is outside already. Remember, this is divided by 2. This is equal to n multiplied by, I can rationalize this as 2n squared divided by 2, all the same, because I want to have a denominator of 2, plus 3n, that is 3n plus 3 if you expand it, still divide by 2, then minus 2 over 2, which is the same thing as negative 1. This is equal to n multiplied by 2n squared plus 3n plus 3 minus 2, all divided by 2 because they have a common denominator. This is equal to n multiplied by 2n squared plus 3n. 3 minus 2 is 1, so we have plus 1. I can even bring out the 2, it doesn't matter. This is a quadratic expression that can be factorized. We take the leading coefficient, we multiply by the constant term, we get 2. Then we think of two numbers that can be multiplied to get 2, but when we add them together, we get 3. The numbers are 2 and 1. If you multiply this, you get 2. If you add them, you get 3. So we can replace 3n with 2n plus n. This is equal to n divided by 2. Don't forget we have a term to the left-hand side. We have 2n squared plus 2n plus n, then plus 1. This is equal to n divided by 2. Among these two terms, we have 2n in common, 2n, n plus 1. Then from this, we have only a factor of 1, n plus 1. So you can see we have n plus 1 in common. So we have n over 2, n plus 1 times 2n plus 1. This is what we have to the right-hand side. But remember, what we have to the left-hand side is this. That is 3 times the summation of k squared. 3 times the summation of k squared. K from 1 down to n. So we can confidently divide both sides by 3 or multiply both sides by 1 over 3, all the same. So summation of k squared from 1 down to n is equal to n divided by 2 times 3 is 6, multiplied by n plus 1, multiplied by 2n plus 1. So we have generated 3 formulas so far for the constant for k and k squared. So let me write them here. The first one is the summation of a constant, c, from 1 down to n. We say that this is the same thing as nc. And the second one, we say that the summation of k, which k starts from 1 down to n, is the same thing as n times n plus 1 divided by 2. And lastly, if we have summation of k squared, where k begins with 1 and stops at n, is the same thing as this one, which we can write as n times n plus 1 multiplied by 2n plus 1 divided by 6. So these 3 formulas are very important in simplifying or evaluating sigma notations. So whenever you have a constant and the summation begins with 1, all you have to do is to take that constant and multiply by n. If it is a variable k, it could be a, b, c, it doesn't matter. Once it is a variable, linear, just use this formula, n times n plus 1 divided by 2. All you have to do, if you are given this, just substitute the upper limit into this formula, simplify and get the final result. And if you are given k squared, this is what you have to use. All you have to do is to substitute the upper limit into the main formula, evaluate, simplify, and get the final answer. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.